What if the line between human and machine was no longer obvious at first glance, and the robot standing in front of you could walk, talk, think, and learn almost like a real person? That question perfectly sets the stage for the Bomi humanoid robot, a new generation humanoid AI robot designed to bring advanced robotics closer to everyday reality. Because at first sight, Bomi immediately feels less like a cold machine, and more like a carefully engineered digital being with human-inspired presence. Standing at roughly human waist-to-chest height with a balanced, proportional build that avoids looking bulky or toy-like, instead presenting a sleek, modern silhouette with smooth body panels, exposed yet refined joints, and a clean futuristic aesthetic that blends industrial robotics with consumer-friendly design, making it feel equally at home in a laboratory, workplace, or demonstration environment, while its facial structure, LED-based eyes, and subtle head movements give it a surprisingly expressive look that adds to its realism without trying to overdo hyperhuman features, which is a smart design choice because it avoids the uncanny valley while still feeling alive. When Bomi starts moving, that first impression becomes even stronger as it's walking. Motion shows controlled balance and natural weight transfer, with each step placed carefully. Through coordinated leg actuators and real-time sensor feedback, allowing it to walk forward, turn, and stop smoothly rather than with the stiff, robotic jerks seen in older humanoids. And while it may not sprint like an athlete, its ability to adjust posture, maintain stability, gesture with its arms, bend slightly at the knees, and rotate its torso gives it a level of human likeness that is impressive for its category, especially when it uses hand and arm gestures to support communication, which makes interactions feel more intuitive and less mechanical. Where Bomi truly aims to stand out is in its cognitive and interactive abilities, because this robot is not just following pre-programmed motions but relies on AI-driven perception and decision-making, enabling it to recognize voices, respond to spoken commands, process conversational inputs, and adapt its responses based on context, while its head tracking, gaze direction, and responsive movements create the feeling that it is actively listening. And although it does not yet replicate complex human emotions, its facial lighting cues, posture changes, and timing of responses add a layer of personality that enhances user engagement, especially in educational or demonstration settings. And from an intelligence perspective, Bomi is designed to learn through updates and training models, meaning its problem-solving capabilities can improve over time, allowing it to handle basic task planning, object interaction, and situational awareness rather than functioning as a static showcase robot. Under the surface, the technical hardware is where Bomi quietly proves its seriousness, as it integrates multiple cameras for vision, depth perception sensors for spatial awareness, microphones for voice recognition, and a network of joint sensors that constantly monitor position, load, and balance, all powered by an onboard processing system optimized for real-time AI tasks, while its actuators are tuned for smooth motion rather than raw strength, prioritizing efficiency, safety, and precision, and its battery system is engineered to support extended operation cycles, suitable for demonstrations, training sessions, or light-duty work without excessive downtime, which makes it practical rather than purely experimental. When we talk about real-world applications, Bomi fits naturally into roles such as educational robotics, AI research platforms, customer interaction demonstrations, guided tours, light industrial assistance, and human-robot interaction studies, because its humanoid form allows developers and organizations to test how people naturally respond to robots that move and communicate in familiar ways, and in controlled environments it could assist with simple logistics, inspections, or collaborative tasks alongside humans, while in academic and R&D spaces it becomes a valuable tool for experimenting with motion algorithms, conversational AI, and embodied intelligence. Compared to other humanoid robots on the market, Bomi positions itself as a more accessible and practical option, as it does not try to directly compete with extremely advanced and expensive platforms like Tesla Optimus or Boston Dynamics Atlas, which focus on heavy industrial performance and extreme mobility, but instead aligns more closely with entry to mid-level humanoids such as Ubtech's Alpha Series or Unitree's smaller humanoid platforms, offering a balance of realistic movement, AI interaction, and affordability, though its limitations are clear in areas like heavy lifting, complex autonomous reasoning, and long-duration independent work, which remain challenges for most humanoid robots at this stage. Ultimately, the verdict on the Bomi humanoid robot is that it represents an important and exciting step toward making humanoid AI more approachable, practical, and relevant beyond research labs, making it ideal for educators, developers, tech companies, and content creators who want a realistic humanoid platform without venturing into ultra-high budget territory, while also reminding us that the future of humanoid robots is not about instant perfection, but about steady progress, where machines like Bomi gradually become more capable, more intelligent, and more integrated into human environments, signaling a future where working alongside humanoid AI may feel far more natural than we ever expected.